Welcome back, focused learners, to another explainer. Today, we're turning our attention to an absolute titan of history. We're talking about an immortal guide in the scientific world, the great Sir Isaac Newton. If you've ever found yourself wanting to truly grasp how the physical rules of our universe were first decoded, well, this is the man whose name became famous worldwide for doing exactly that. But before we get into the nitty-gritty details of his life and his work, I want to pose a compelling question to you. What truly makes a great scientist? Is it just having this sharp, unyielding, massive intellect? Well, actually, the answer involves actively challenging old beliefs, rather than just being incredibly smart. It requires a very specific, almost rebellious mindset.
All right, Section 1, The Legend of the Apple.
Okay, let's dive right into this. And honestly, there really is no better place to start than with the most universally famous, iconic story about Newton. Picture this. The year is 1686. You've got a brilliantly sharp, nature-loving scientist sitting quietly under an apple tree. And then, as the legendary story goes, an apple simply falls and hits him right on the head. It's a charming, kind of funny image, isn't it? This brilliant mind just randomly interrupted by a falling piece of fruit. But here is the crucial point. From that incredibly simple, everyday event, a monumental discovery was born. Observing that falling apple sparked Newton to discover the law of gravity, right then, in 1686. This was a foundational achievement of his entire scientific mentality. Because, see, it wasn't just about an apple dropping. It was about his mind being open enough to step back and formulate the actual rules of why it fell. Moving right along to Section 2, Timeline of a Genius. It's fascinating because even from his childhood, Newton was already this intense builder and observer. He was creating these incredibly good models of air mills, watches, and toys as a kid. Born on December 25th, 1642, in Ulsterp, England, his brilliance showed up really early. By 1665, he'd passed his diploma at the prestigious Trinity College of Cambridge University, where he'd later work as a professor. But his influence wasn't just kept in the classroom, right? In 1689, he actually served as a member of parliament representing the World School. And then, by 1703, he hit the absolute pinnacle of scientific leadership, becoming president of the Royal Society in London. That's a massive, massive position he held for the rest of his life, up until his death in London on March 20th, 1727. Which brings us to Section 3, the rules of movement. So we've talked about gravity, but 1687 was the year Newton executed his incredibly famous scientific beliefs about motion. And let me tell you, the execution of these rules completely revolutionized physics. These principles perfectly showcase his sharp intellect, and they provide a framework that scientists around the entire world literally still rely on today. Let's break these down one by one so we can truly grasp the whole shebang. The first rule of move is essentially what we call inertia today. The rule states that over each pinda, or object, it stays in a stable condition. Or, if it's already in movement, it's going to continue moving in a simple, straight line without stopping. It'll just keep doing exactly what it's doing, unless an outdoor ball, which is a really fascinating translation from our source text for an outside force, is used upon it. It's brilliantly simple. Things just want to keep doing exactly what they're already doing. Now, let's look at the second rule of move and see how this builds. This rule states that preveg, which means acceleration, is proportional to the ball or the force supplied, and inversely proportional to the pinda, or the mass of the object. To put that into clear, everyday terms, how quickly the speed of an object changes depends directly on how hard you push it and how heavy that object is. Makes perfect sense, right? And finally, the third rule of move. Every action always has an equal but opposite reaction. It is a beautifully symmetrical concept. Forces always come in pairs. When you push on the world pushes back with the exact same amount of force. It's this perfect underlying rhythm that dictates the physical interactions of our entire universe. Next up, Section 4, Unlocking the 7 Colors. Now, what's really interesting here is that Newton wasn't quite done reshaping our understanding of reality. Shifting focus to his physical tests beyond just gravity and movement, we land on a fascinating number, 7. Newton brilliantly used a prism to prove that pure white light isn't just one blank single thing. The result of his tests showed that there are actually 7 distinct colors hidden within light. He effectively unlocked the rainbow, proving it through rigorous, undeniable physical testing. And finally, Section 5, the power of doubt. Let's step back and reflect for a second.
What was the true philosophical core of Newton's genius? A core that was shared by later giants like Albert Einstein. It all comes down to the stark contrast between doubt and faith. Our source text makes an absolutely fascinating point here. Faith, in this specific context, is described as believing with closed eyes. And if someone believes with closed eyes, they can never truly become a scientist. They're just unable to get science, because accepting old beliefs blindly means you completely lack the capability to imagine new rules, like gravitational forces or the rules of movement. Doubt, therefore, is the true engine of the scientific mentality.
Newton summed this up perfectly. He said, "The main basic of scientific mentality is doubt, not faith." This is absolutely crucial. Newton's ability to doubt, to actively question the world around him, and to challenge those old beliefs is exactly what made him great. If he had just accepted the standard beliefs of his time, there is no way he would have had the capability to imagine anything new. So when we consider his immortal legacy today, it is truly staggering. He executed the rules of movement, he discovered gravity, he unlocked the 7 colors of light, and above all, he challenged old beliefs. Even though he's no longer with us, his scientific success has become a guiding principle for the entire world. And that right there is exactly why we will always honor and adore Newton as an immortal guide in the scientific world. Which brings us to our final provocative question for you to ponder. How will you use the power of doubt to challenge old beliefs in your own world today? I really want to challenge you to actively apply Newton's scientific mentality to your own lifelong learning. Question everything, keep your eyes wide open, and never, ever stop exploring. Thank you so much for joining me on this explainer, and keep learning.